Hey guys, so in this lesson we're going to look at the law of cosines, which is another method we can use to solve oblique triangles. So if you recall from the last lesson, we said if we have an oblique triangle, meaning that there are no right angles, we can't use SOHCAHTOA and we can't use Pythagorean theorem. And so we learn how to use the law of sines, which requires that we have a matched set. So in order to use law of sines, we need to know the measure of one side and the measure of the angle that is opposite that side of a triangle. Now, if we don't have a matched set, then we can use law of cosines. So the law of cosines can be written in three ways. On the left, you see a triangle ABC, and then the corresponding sides opposite those angles are labeled little a, little b, and little c. And so we always start with the law of cosines with the side that we're looking for. So if we're looking for side C, we start the equation with c squared. If we're looking for side B, we start with b squared. And if we're looking for side A, we start with a squared. And it's very similar to Pythagorean theorem. C squared is going to be equal to a squared plus b squared, where a and b are the other two sides, minus 2ab times the cosine of c. So when you are using the law of cosines, we always start with the side that we're looking for, or if we're looking for an angle, we start with the side that is opposite the angle that we're looking for. So for example, we're trying to solve for angle C, then I start my equation with little c squared. If we're looking for angle B, then I start my equation with little b squared. And if we're looking for angle A, then we start with a squared. So let's look at an example. In example 1, we have a triangle ABC, and we're looking for side A given angle A, side B, and side C. So let's again start by drawing a diagram. I'm going to draw any triangle ABC, not drawn to scale, and I'm going to label it. So I know angle A is 65 degrees, B is 8, and C is 10. And I'm looking for side A. So given any oblique triangle, we know we can't use Pythag and we can't use SOHCAHTOA. So the first thing we're going to try to use is always law of sines, because that's a little bit easier to remember than the law of cosines. So we look for a matched set. I don't have one, and I can't figure out one based on the information that we're given. So we can't use law of sines, and now we're left with law of cosines. And because I'm looking for angle for side A, I'm going to start my equation with A. So a squared is going to be equal to b squared plus c squared, the other two sides, minus 2bc times the cosine of angle A. So the cosine of that angle always matches with the side that we start with in the equation. And so let's put that information in. I have a squared is going to be equal to 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 65 degrees. And a is almost by itself. The only thing left would be to get rid of that squared, so what we can do is take the square root of both sides, and the square root cancels out the square, and in your calculator you can actually type all of that in. A is equal to the square root of, or you could simplify 8 squared to 64 and 10 squared to 100, up to you. But you could type it in just as is, as long as you're careful of your parentheses and your exponents. So minus 2 parentheses 8 parentheses 10 times the cosine of 65 degrees. They are all under the square root. Make sure your calculator is in degree mode. And if we round to the nearest tenth or nearest hundred, that will be 9.82 units long. To the nearest hundred, 9.82 units long. Let's look at one more example. So in example 2, we've got triangle ABC. And we're looking for angle C, and given instead of an angle, Now we're given 3 sides instead. So again, always start by drawing a diagram if it's not already given to us. And your diagram doesn't have to be drawn to scale as long as you label everything correctly. So little a is 5, little b is 7, and little c is 10, and we're looking for angle C. So again, looking at the information that is given, it looks like I can't use PyDiag, can't use SOHCAHTOA. Those would be the easiest and most familiar if I have a right triangle, but I don't. So the next thing I ask myself is, alright, can I use law of sines? Do I have a match set? And in this case, we don't. So now we use law of cosines. And because we're looking for angle C, I'm going to start the equation with the side opposite angle C, so little c. So my equation is going to be c squared is going to be equal to a squared plus b squared, the other two sides that I'm not looking for, minus 2ab times the cosine of c. And let's go ahead and substitute our information in. So 10 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of angle C that I'm looking for. And then we're going to go ahead and simplify to solve for C. 100 equals 25 plus 49 minus 70 times the cosine of C. And now here is where a very common mistake happens, so be very, very careful. When you're trying to isolate C, a lot of students would say, all right, how about we can combine like terms on the right side, right? We can add 25 and 49. Yes, you can. Now, the thing that I want you to be careful with is make sure you know that after you add 25 and 49, you cannot subtract 70 because that 70 is being multiplied to the cosine of C. In order of operations, you have to do multiplication before adding and subtracting. And because we don't know what angle C is, we can't multiply 70 by the cosine of C, and therefore we can't subtract. So be very careful when you are simplifying. This is going to give me 74 minus 70 times the cosine of C that I can't combine. And then I'm going to subtract 74 on both sides to try to isolate that C. And we've got 26 equals negative 70 times the cosine of angle C. And keep isolating the C. I'm going to divide both sides by negative 70. Okay, and I'm going to, again, try not to round until the end. So I'm just going to keep it as a fraction. Negative 26 over 70. You can certainly simplify that fraction if you want to. Equals the cosine of angle C, and then finally to solve for angle C, we're going to get rid of cosine by taking the cosine inverse of both sides. And so angle C is going to be equal to, in my calculator, I'm going to type in the cosine inverse of negative 26 over 70. And again, if you want to calculate negative 26 over 70 in your calculator, you can do that. Press enter, and then do cosine inverse second answer to input that answer in so you don't have to do rounding in between. And that's going to give us roughly 111.8 degrees for angle C. Okay, so be very careful when you are solving for an angle using law of cosines. Make sure that you isolate it accurately and try not to, remember not to combine the a squared plus b squared minus 2ac, can't subtract. Solving for a side is a little bit easier. So I now know that this is 111.8 degrees. And that's what I'm looking for. Now, what if, and it's not asking this problem, but what if I ask you to solve for the triangle? So what if I ask you to find every piece of missing information in that triangle? The only thing left to do is to find the measure of angle A and the measure of angle B. because you already know the three sides and you know one of the angles. So let's do this as practice. If I ask you to solve for the rest of this triangle, you're looking for angle A and angle B. You could start with either. So for example, if I want to solve for angle B, you could, if you wanted to, you could use law of cosines again. However, since we already know one of the angles, we could actually use law of sines, right? So to solve for angle A or angle B, you could use law of cosines again, but now that we found one angle and we have a match set, let's go ahead and use our match set. So if I'm looking for angle B, I would use my match set 10 over the sine of 111.8 degrees equals 7 over the sine of B, and then we can cross multiply. So that's going to give me 10 times the sine of angle B equals 7 times the sine of 111.8 degrees, and then dividing both sides by 10, the sine of B is equal to 7 times the sine of 111.8 degrees all over 10, and now we take the sine inverse of both sides to isolate B. So in your calculator, you're going to type in the sine inverse of all of that. 7 times the sine of 111.8 degrees. Make sure you close the parentheses, all over 10. So you could, again, actually do this out first if you want to, and then you can type into your calculator second answer. So, which is right next to enter where the negative sign is. Second answer will give you your previous answer, so you don't have to type all of that in. But you can type it out in if you want to. Okay, and again, I try not to round until the very end, just to avoid any numbers being a little bit off. But if you are going to round the middle, round to at least 4 places after a decimal, just to be more exact. And that's going to give me the measure of angle B as roughly 40.5 degrees. That would be the measure of angle B. And then once you use law of sines to find angle B, and you know the other angle, you're only missing that one last angle, then we can just use the sum of the interior angles of a triangle, 180, take away 111.8, take away 40.5, and that will give you the measure of angle A as 27.7 degrees. And the whole triangle is now solved. You know all 3 sides and you know all 3 angles. Okay, so when you're solving a oblique triangle that is not a right triangle, we can't use Pythagorean theorem. We can't use SOHCAHTOA. So summary, we're going to always start by trying to use law of sines if you can, by seeing if you have a match set. If you do, you're good to go. If you don't have a match set, then we use law of cosines to help us find one match set. So use the law of cosines once, and then once you have that match set, you can go back to law of sines to solve the rest of the triangle.